welcome back to the second day of the conference. I'm pleased to kick things off and introduce Chris Turner from ThoughtWorks, doing a session on continuous delivery. A few things I want to mention before we get started. Reminder, we have this voting system for collecting feedback based on the session at the back of the room. So if you take, on your way out, if you take one of the gold coins and you deposit it in either the green or the yellow or the red bucket, depending on how you feel about it, where green is good and red is less so, that would be appreciated. And there are also some booklets that ThoughtWorks have provided that are on the table at the back that are free for you to pick up. And Chris was saying that they have, they're going to do a draw for this new book on continuous delivery by Jez Humble and Dave Farley. And that's going to be based on collecting some business cards. So after the session, I'll go get some sort of a bowl that we can put the business cards in if you want to come up and drop yours off. And then we'll announce.
Yeah, we have 5 signed, autographed by
So we'll announce who gets those books after that. And the hotel's going to be bringing in some more chairs, so if you're stuck in the back and are looking for chairs, they will be coming in. Otherwise, there's a few up here in the front row for the keeners. Great, welcome, Chris.
Okay. So first off, I'd like to apologize. I'm kind of at the end of a cold, so I'm going to be coughing and drinking a lot of water today, but should be all right.
You have a mic. You have a mic there. You
Oh.
can use. Yeah.
Yeah. Does that work? So let's start off with who the heck am I? So my background is about 6 years ago, I joined a small company we're doing part-time operations work, working with a lot of smaller organizations, helping them maintain their servers and get things deployed and things, and part-time development work. Then 5 years ago, I joined ThoughtWorks, where I was doing development, build engineer, deployments, pretty much everything related to the build part of it, as well as doing development work. Then I joined the Go team, where I worked there for about 3 years, working on the ThoughtWorks Studios continuous deployment and delivery tool. Recently, I just moved into more of a trainer role, so I'm doing presentations and things like this. So what is continuous delivery? Let's start out with the basic type of a basic Agile project, where we start off with the customer feeds things into the Agile team, which is generally the developers, maybe a few testers, analysts. This is where a lot of the work and what everyone traditionally understands as Agile is. In a lot of bigger organizations, this feature, this project, feeds into a centralized QA team, and they're in charge of making sure that all the different projects, even the non-Agile ones, all work together. And then this feeds into operations where it needs to be put into production and everything needs to work together. This last, after the Agile team, is called the last mile. And this is where traditionally we've had a lot of problems in getting things quickly into production because of the difficulties in getting everything to work together right. So a lot of this started to change with Web 2.0. Flickr, for example, deploys multiple times a day, where they are constantly taking the new features that pass all the tests and get them into production as soon as possible. We're going to talk about what advantages they get from that. But one thing, I don't know if you've seen this, if you go to code.flickr.com, you can actually see the last time they upgraded and who checked in. It was kind of cool. So it gives you a lot of information, and it doesn't really matter, but I think it's kind of. So what do we get out of releasing frequently? We get a lot of feedback from users. Flickr, for example, when they first started out, it wasn't focused on image sharing. actually a subcomponent of a video game that the company was creating. By getting feedback from users very quickly, they realized that there was more usefulness, and people were really excited about the image sharing capabilities, and they switched their organization to focus more on it. The faster the feedback you get, the higher quality, and the easier it is for you to change things to get it to work. Also, it reduces the risk of any individual release. If every release has 500 features, there's a much higher chance of those features causing problems in interactions. Whereas if you have one feature or one part of a feature that gets deployed every release, then the risk of that feature screwing up is much smaller. And also, on the converse of it, if something does go wrong, there's less risk in rolling that feature back or in just waiting until the next release to fix a bug. You get real project progress. If you say your project is 50% done, does that actually mean 50% of the features are completed and ready for users to use? If you're constantly deploying, then that's true. And that's really powerful for the business because they have more capabilities to say, we may only be 60% done with the initial vision of this project, but that's giving us a significant amount of revenue, and it's worth it to cancel the project. And having the business being able to make that call is hugely important. I'm sure all of you have seen the Agile Manifesto since we're at an Agile conference. I want to talk a little bit about not so much the manifesto itself, but the principles behind the manifesto, and specifically the first sentence there. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So the basic understanding of what Agile is getting valuable software delivered to users constantly. This is something we haven't been able to really hit yet because of this last mile problem. And now we're really starting to get to that level. This continues to. The Popovich asked, how long would it take your organization to deploy a change that involves just a single line of code? And do you do this on a repeatable, reliable basis? So for example, if the business realizes that there's a single feature that will add 10% to their revenue, how long would it take for that feature to get from that idea, analyzed, written, tested, put into production, and actually getting that 10% value? This is an important metric, and I would argue one of the most important metrics. It's a team metric. It crosses all parts of the business. And this is what you really want to optimize on, is to get an idea into the hands of the users as quickly as possible. So continuous delivery is about taking the development team, the testing team, and the ops team, and constantly putting new features into production. One side effect of this is software is always production ready. So what that means is at any point the business can say, this is good to go. And the releases are now tied to business need, not operational constraints. At any point the business can say, we're good. But keep in mind that doesn't mean that the business is always saying, every hour or so I need this into production. This means the business can make a conscious decision of saying, this set of features is ready to go into production, which means they can have marketing around that. They can do all sorts of things. But again, it's the business itself that is the constraint here, no longer the dev team or the ops team. If anyone has any questions, just raise your hand. And I'd rather do it while I'm in the flow of things than wait to the end. So let's talk a little bit about the deployment plan. So here's what's the ideal situation that we could possibly come up with. So software is always production ready. We have reliable deployments. We know that even though we have this code, it's not always guaranteed that putting it into production will be a non-event. there's a lot of interactions with software on on the server itself. There's interactions with other components within the system. So we want to make sure that we have reliable deployments. Everyone can self-service deployments. This means you don't need Bob from Ops to be working that day in order to fix a production issue. If a deployment happens, anyone should be able to make the deployment happen and also roll it back. That doesn't mean that anyone can just hop onto the server and install the software. There needs to be processes built in so that it's repeatable and reliable. And again, releases happen according to business needs, not operational constraints. So let's look at some of the principles here. We want to create a repeatable process for releasing software. What this comes down to is, we're going to talk a little bit about automation in a little bit, but the most important thing is that what we do is written down in such a way that it will always work consistently. But one side effect of this is we need to make sure that we're testing how we would be deploying into production, which means having some sort of staging environment that is as close to production as possible. And testing it constantly, testing the rollback procedures to make sure that if something does go wrong, which it will at some point, that you can get back to a previous version that was working quickly and without risk. Automate everything you possibly can. So the build system, deployment, testing, releasing. Computers are really good at repeating the same things over and over again. Humans are not. So having written steps to do it is the reason why a lot of deployments have issues. People sometimes miss steps, or they do the order wrong because they think it'll be faster. A lot of times deployments happen at 3 a.m. on a Sunday. People are not in the best of mind at 3 a.m. on a Sunday. Having everything automated reduces the risk of what will happen. There's some things you just cannot automate. Manual testing, for one, is actually an important aspect, and you need to have some sort of way to be able to do exploratory testing and testing things. But so this implies that you don't often want to have a check-in going all the way into production. You want to have some QA have the capability to manually look at the app, make sure that things are working as they expect. Keep everything in version control. This includes database scripts. This includes the software, obviously. This includes infrastructure configuration, dependencies, middleware. It should be possible to go to basically any machine, check out the source code, and type a single command to set up the environment in such a way that the build can be there. This might involve having it automatically install packages on the system, but basically we want everything in version control so we have a system of record. So we know what has changed this system. If it's a configuration change, that's just as important as the source code. And you want to know who made that change, so you can follow that back. This is the basic principle of continuous integration: is if it hurts more, or if it hurts, do it more often. It's much like exercising. If you only exercise once a year, then trust me, it hurts. And if you do it every day, then you have tricks. You are more fit, so you know how to make it hurt less. It changes the philosophy on how you do things by bringing the pain forward. Build quality into the process. Testing is not a phase. Everyone is in charge of keeping the quality high. If that means that a developer notices that there could be a bug around here and they have to push back saying, I can't finish a feature now, everyone needs to be aware that that's a good decision. We need to do basically the quicker you catch a bug, the cheaper it is to fix it. If it gets all the way into production, it's something like 100 times more expensive to fix, because the developer has to find where the bug was. They have to understand what they did, 6 months ago. They have to fix it. It has to go through the entire QA cycle to be able to make sure you're not introducing new bugs. But if a developer or QA finds it immediately, and before it even gets into production, much better. As Demi says, cease dependence on mass inspection to achieve quality. Don't count on people looking at it. Improve the process and the build quality in the first place. Done means released. It is not just dev complete. A feature is not done until it's giving value to the business. If the project's canceled and you haven't gotten into production, it's not technically done in that case. This is an important thing because it brings everyone together with the same goal of marking this story or this feature as done implies that you have to be involved in operations, with testing, with analysts, with developers, everyone with the business to decide whether to bring it out there, or that to help describe what they actually want. Bringing everything together is why this is so important. And on part of that is everybody is responsible for delivery. Everyone needs to be communicating and understanding what is involved in delivery. I've seen many situations where the developers don't understand the requirements that ops has. And this, I'm not even talking about like organizational requirements, but operations has certain things that they just need to take care of. They need to have logging so that they can understand what they need to do to the system. They need to have be able to configure the system. If they're running out of threads in a web server, they need to be able to up the thread count. It's this kind of thing that if you don't have, if you don't build in ways to configure this without causing a recompile, operations team life is significantly worse. This is a major culture change, getting everyone bought into this idea that it's not just throw something over the wall and your job is to get it out of your domain. This is, everyone is involved in bringing value to business. And also continuous improvement. This means making sure that the entire process is tuned as tight as it possibly can. If somebody notices that we're spending a lot of time in a certain area, there may be something we can do to fix that. And having everybody look at this and try to fix it is important. A lot of this comes out of Lean, which value stream mapping is really useful for trying to understand what's going on in your process. This is the manual process, the build process, everything. Effectively, I don't know if you've seen this before, but what you do is you map out everything you do and how long it takes. But you also map out how long you separate the concept of how long it takes to do something from how long it takes when you're waiting. And what you want to do is cut back the wait times as much as you possibly can. Between development and testing, there's a five-day lead time there, which means that it's probably installing on a server, something like that. If you can automate that to make it faster, you can cut down that lead time, you can improve the overall process. The build pipeline itself is the everything you can automate effectively. It's everything from where a developer checks into source control to the testing that happens, deployments into manual testing environments, deployments into production. Basically everything that you can automate is involved in the build pipeline. So what are our prerequisites for having a continuous delivery build pipeline situation? Comprehensive configuration management. This is really vital. Not having any idea what specific version is installed in what specific server can kill a project. You need to be able to know what apps are installed, what versions of those apps. If only Bob the ops guy knows that the production server has version 3 of Jetty, I don't know what version those are, but version one version of Jetty and the staging environment has a different version. Everyone needs to be aware of that. So you want to automate this configuration management in such a way that you have it checked into source control. Everyone knows what is currently in those environments. You need automated testing like crazy. The speed that you go with this situation, with continuous delivery load pipelining, doesn't support having testers have to manually go through every regression possible. Automated testing is vital for that reason. And again, like I said before, computers are really good at doing the same thing over and over again. So having that baked in also means that your testers aren't missing things. Continuous integration, vital. Having the developers' work constantly merged together and tested together is really important at the beginning of the process to make sure that you can find out as soon as possible what the problems are. We'll get into that now. So here's a way to look at the deployment pipeline. In this case, the developer checks into version control. This kicks off a build pipeline that just builds the code, so it does a compile, and runs fast unit tests. This usually takes less than 10 minutes, usually about 5 minutes, very fast. The developer is in a headspace of knowing what they did. In this case, the test fails. The developer is notified. They fix the bug, figure out what it was. Check it in. It runs those fast tests again. The developer gets feedback that it passed, which means that they can move on now and work on other stories. They can work on other features, other parts of this feature. They no longer are worried about it too much. In the meantime, after the initial stage happens, the automated acceptance testing are running. Automated acceptance testing usually takes significantly longer. It can take multiple hours even. This is the running with a real app, testing out exactly what the organization, what features the organization cares about. Developer gets feedback from this, maybe an hour later. They're not quite in the same space, so it takes a little bit for them to figure out what was happening. They fix it, check it in. It's all the way to automated acceptance testing. And at this point, everyone is aware that we have something that automatically, from our automated tests, are aware that it is actually working. It's valid. So at this point, the QA may decide, okay, I need to do some exploratory testing. I need to try out some different things. The interactions I'm not quite sure on. So they manually click a button, which automatically deploys into some sort of QA environment, UAT environment. At this point, they can play around with it. They can try it out. An important point, though, is the QA is doing a pull system of saying, I'm ready for this release to test out. QAs get very annoyed if you're constantly deploying to their service that they're testing. So having the capability of deciding when things go into their environment, but without them having to know what it takes to deploy or having to go through steps to deploy means that at any point they can decide, I'm ready to look at it. When the QA decides, hey, this is good as far as I can tell, everything's working well. At that point, you can decide to push it into the release. Push it into production. Usually there's a staging environment at some point to make sure that it's going to work when it comes to production. So another way to look at this deployment pipeline is the farther along we get into the pipeline, the more confidence we have that it will work in production effectively. And part of that is because the environments that we're deploying to and testing on are becoming more production-like the further along we get. On the flip side of that, we get faster feedback earlier. So, for example, the more production-like means in production we're using Oracle database. So in some of our staging environments, we're probably using some sort of Oracle. We may have clustering on production, but not clustered in an earlier stage. The developer part, though, we don't want to take the time to make a database connection on every test. We don't want, we can't afford an Oracle license on every single developer team, something like that. But so the developers will maybe fake out the database in a lot of their unit tests, or they may use an in-memory database to keep things really quick. Again, we want to keep that first step down to 5 minutes or so that the developer knows what's going on. There's 4 major types of stages that we've seen in organizations. There may be more, depending on your situation. The commit stage, which works at the technical level. This is focused on does the interactions within the code work the way that the developer expects. The acceptance test staging is at the functional and non-functional level. This is where the business is saying, I want, when I click here, it'll change the address. The business cares about that situation. A lot of the unit tests may have some sort of test around that, but the functional will actually work with a real database and will work with a real server setup. The third is the manual test stage, which is mostly exploratory testing. It could be ensuring that the translations are working. If you have to have multiple translations of your app, you want to have somebody that manually goes through that. It's really difficult to automate those kind of things because you just duplicate yourself in your test, which is not adding value. So having somebody manually look at it and make sure that the French actually reads correctly is very important. And then finally, the release stage, which is the part that delivers into different environments the app that you have. So here's a view that Go uses to display the pipeline. As you can see here, we see every source code revision that was checked in, and we can see how far it got into the pipeline. The first check-in, revision 30, it looks like, failed at the build stage, so the initial commit thing. 31 checked in, it gets all the way into production. From here, you can easily see that there's 2 builds, 31 and 33, that are capable of going to production. They passed UAT. They got as far as we care about from an automated point of view. And just clicking on it will deploy it into that environment. Yeah?
So when you're talking about automated acceptance tests,
Yep.
are you talking about like a Selenium type of testing?
Yep.
Okay.
Selenium's one tool. I've used Twist quite a bit, which is really good for it. There's a lot of testing tools for it.
Right.
But yeah, we're talking mostly about something that drives through the UI that the user uses.
Right. So mimics a user
Yeah.
user's activity.
Exactly. Yep. So the commit stage. This runs against every single check-in that happens. You want to parallelize this as much as you possibly can. If you're building a bunch of components, you want this to happen quickly. Sometimes your tests take a little bit. You split those up. This will create a release candidate. This will create a binary that you will use in later steps. There's an important reason for doing this. You want the things that you're testing throughout the entire environment, every environment, you want to make sure that you're testing the same thing. I've seen a situation where we ran the test and the acceptance test, compiling with a Java compiler, but it was recompiled for later deployment using a different, I can't remember which compiler it was, but it actually subtly changed something within the app. So when it went to production, there was a bug that would have been caught if we had used the same compiler throughout. So by using that compiler at the beginning and using the binary, so a jar in Java, a zip file if you're using a scripting language like Ruby or something. But having that single binary that you work through gives you knowledge and understanding that you're testing against the exact same thing that you're working through the system. And if it fails, fix it now. Actually, this is especially true with some of the later ones where it's more, you're more willing to let things go. On the, actually it's on the Go team. We had an acceptance test, we used Twist. We were doing a pretty major refactoring of the architecture underneath, and we knew that there were about 3 Twist tests that were flaky. So they would sometimes work, sometimes not. The features were working, but it itself was not. And so the stage was red. It was counted as failing, but we knew it wasn't really failing, and so we just kind of let it go while we were working on this major refactoring. We figured as soon as we spent 3 weeks on this major architectural change, we go back and fix it. So all those 3 weeks, our acceptance test was red, not working. When we went back, we found that it wasn't the 3 flaky ones that we thought it was. It was like 20 different tests, and about 7 of them were actually proving out that we broke functionality. When you get used to having a stage go red, it means you no longer are paying attention to it. So you want to do everything you can to ensure that something stays green. With acceptance testing, that can be really hard because of flaky tests, as I said, but the value you get out of it is huge. The acceptance stage. With this, you want to start getting as production-like as you possibly can. Again, possibly can is a wide range. You may not want to bother if you have a 100-node cluster in your app. You may not need 100 machines to test this accurately. But you want to try to get it as close as possible. You need to smoke test the deployment. So automatically, after an app is automatically deployed, you want to run some sort of quick automated test that proves that at the very least you can get to the app. Nothing is horribly wrong. The web server is up, there's a few pages available, things like that. An important part of that, though, is if it isn't up, then it should roll back to a previous version. All automatically. This gives you confidence that when I deploy, at the very least, I can get to some part of the app. It might not be, completely working. We'll run tests to make that happen, but to verify that it's working. But you want to run a quick smoke test to make sure that. At this point, then you need to run your automated tests, your Selenium tests, your Twist tests, everything that will work through the app as a user. And then you need to tear down the environment in such a way, but especially between tests, you want to make sure that your tests aren't dependent on each other. It takes a lot of work to try to keep things independent, but especially if when you realize, so acceptance testing tends to take a long time. For example, the Mingle team, they have Selenium tests that I think it's like 30 hours end to end in order to run everything. It's way too long for them. So they use a build grid to run all the tests concurrently. Well, not all, but they have it. So instead of being 30 hours, they have about an hour, I think now, just over an hour, spread across 30 machines. So by having that capability can only happen if your tests are independent. The fact that they can split these tests however they need, the ordering on it doesn't matter at all. And also, if you don't have a teardown part of it, it can be very frustrating to try to figure out what's going on, what's wrong. It's horrible when you see that it's failing. The developer checks it out, runs the acceptance test, and it's working fine. And it's only because 4 tests before it inserted a row into the database that screws up this test. How do we do manual stages? It's actually a lot like the acceptance, the first 2 parts of the acceptance. You deploy to a production-like environment, and you run a quick smoke test, again, to make sure that it's working, and rolling back if it doesn't. At this point, then, the QA, the business, anyone can start using the app, playing around with it, trying new things, creating new records. So, quick recap of the practices. Only build your binaries once. Like I said before, you want to make sure that you're using the same binary throughout the entire process. Deploy the same way to every environment. This gives you confidence that your deployment process works correctly. If the first time you test your deployment process is when it goes into production, there's a good chance that you're going to break everything. And again, you don't want to be doing that at 3 a.m. on site. Smoke test your deployments. Automatically verify that they're running at a basic level. Keep your environments as similar as you possibly can. Again, this comes down to if the only time you ever touch Oracle is when it's in production, there's a big chance that you're going to screw everything up. And then finally, if anything fails at all, stop the line, figure out what's going on, make it better. So how do we make this happen? First of all, figure out what your process is. Write it down. Make sure everyone agrees that this is how we get things from a developer checking in into production. And then create a walking skeleton. In whatever automated tool you're using, Anthill Pro, Go, some custom thing you write, have empty steps in the process that you can use to fill in automated steps at a later point. This gives everyone visibility into where things are in the process. Even if those steps will just go green whenever you hit it, or go red whenever you hit another button. It's important to be able to model it so everyone is aware how far that's in. Next step is to automate the build and deployment process. Everything feeds off of this automated build. So you need something that will compile, create the binaries. And then also, for the deployment process, at the very minimum, we'll deploy these binaries into some sort of user acceptance testing environment, something. This will give you a baseline for how to do delivery later, how to get the code ready for production. And again, your QAs will love you if you automate your deployment process so you don't have to manually install it. Next is automate the unit tests and code analysis. Effectively, what we're doing here is we're fleshing out the initial commit stage. The sooner you can get this set up, the faster the rest of everything else will run. The developer feedback you want to happen quickly. Developers will start to be, this is the CI, the continuous integration part of it. Developers will be able to rely now on functionality changes being caught, or bugs being introduced, being caught by unit tests. Once you get your unit tests and your code analysis ready, next is the acceptance test. This tends to be one of the most difficult. From a flaky aspect, how things render on the page can actually impact them. Changes that you think wouldn't affect a certain test will break it. A significant amount of time is spent maintaining and automating your acceptance tests on a fully active tool. But the value you get is massive. Skipping, not having to have the QAs focus on regression leaves them the capability to focus more on the stuff they actually enjoy, which is exploratory testing, boundary testing, the more fun stuff, just trying to bust it. And then finally, get to automating your releases. There's an important reason why this is last, because if you don't have everything else automated before this, you don't have any, you're not positive that what's going into production is something that's tested. And having your releases set up in an automated fashion, you want to have that confidence that we know what's happening. All right. So how do we go live? You need some sort of release plan. This release plan is going to have a bunch of different parts to it. Written down, step-by-step deployment procedure. This may be automated scripts that you need to install. It may be you have to log into this machine and double-click the zip file, or everything should be listed here that happens. The application that you use to smoke test it, any dependent services that you rely on, if you have to connect to another component within your organization, what versions work with your app, you need all this information built into your release plan so that when somebody is doing a release, they know that everything is set up the way it is. Rollback procedure is huge. You need to have some way of going from the new version that doesn't work back to a version that you know works because the users have been using it. There's a bunch of tricks we're going to talk about on how to make rollback possible and useful. But having a procedure written down in your release plan is important, so because that's going to be the thing that saves your job. Any known dangers and coping plans. Again, a lot of these releases happen really early, and the developers are not available to talk to, or not all the developers are available to talk to the operations team. Having some things that you know may pop up and tricks to get around that can save headaches across the board. And rehearse. Go do this release plan over and over again on some sort of staging environment, to ensure that it is actually living in reality. The release plans, the longer they're out, the less valid they are. So having rehearsals to make sure that what we're saying here is actually works with the current version of the app is really important. And also the rollback, to make sure that when things go bad, I can get back to a version of my app that is working. This also implies testing backups. What happens when in the middle of an install when the hard drive crashes. You need to have practice this and understand what is going to happen. So there's a few rollback strategies here. Blue-green deployments. So say we have a web server, an app server, and a database server. We're going to call these blue environments. So this is these three servers. The user is going through a router and connecting to your version 1.1 of your app. While this is running, the user is using it, we set up 3 new machines, web server, app server, and DB server. This is the green environment. We install version 1.2 of the app, we copy the data over from the database. Again, the user never sees this, but it's running as if it was a real usable environment. Yeah?
Are you talking about the same physical servers or separate instances of the application?
You can do either. So you can either, using different ports, you can use the same machine. There's trade-offs to that. It's cheaper because you don't have to have a duplicate of everything in your production, but it also can have performance impacts. If you're running at 90% on your web server, you can't afford to have another one running. So it just depends on what your situation is. So once you get this up, a simple router switch, and everyone's going to the new version of your app. The old version's still sitting there waiting for if things go wrong, you can just switch people back. What do we get out of this? As far as the user's concerned, this is a sub-second upgrade. It is pretty much instantaneous. They're using version 1.1, and all of a sudden they're using version 1.2. This gives you the capability to warm up the cache on your server. There can be significant performance issues if the database cache, the web server cache, is not at a state where it can avoid round trips all the way to the database in a lot of cases. If the user is using your app and they're used to sub-second response times, and all of a sudden it takes a minute because you switch your app, you may lose customers, you may lose money. Having this capability to automatically warm up the cache on everything, huge advantage. This is the thing I think is the biggest advantage here. When things go wrong and you roll back, you now have the new version of the app sitting there broken. So now developers can hop onto that machine, they can look at the database, they can look at the server, they can try to figure it out. If you don't have this capability, especially like if you use a shared database, for example, a lot of times it becomes very obnoxious. And I've been in situations where we decided to leave it broken, not horribly broken, but some part of the system was broken, because the developers needed to be able to connect to and debug it, because they had no idea where it was happening. Having this on a completely separate server means debugging is significant. What does it take to do blue-green deployments? Obviously, a duplicate of the servers or some way of duplicating the systems underneath. Can be very expensive, but there is some organizations, Jess mentions it in the book, and I can't think of what he calls it, but where you use the staging environment as the green environment, and then you swap them. So the production becomes a staging, which gives you the capability of having a staging environment that is literally production ready, while keeping the cost down a little bit. Again, you don't want to practice on the staging and then leave that practice. You want to still try the staging and then make a full feature release, but having that can really help. The biggest trick with blue-green deployments is around the database. The time it takes from having the database copied over to when you switch people from blue to green, you need to ensure that the data is kept consistent. It can be very tricky. There's tricks you can use, like mark the database as read-only while you're doing this transfer, but and there's something I'm going to cover I think in a little bit. That's another way to do it. And then the rollback. If, for example, a user is using 1.2 of your app and changes their address, when you roll back, their address should still be changed. So you need to move data back as well, even though the database schema might be different in this case. Very tricky stuff. So one thing you can use to deal with keeping the databases in sync is a trick called event sourcing. So in this situation, we have a user, John Smith, is in the database with an address that they're in Portland. They want to change their address. So we just do a delete of the old address, add a new address. Pretty standard stuff. With event sourcing, what we do when they want to change an address is we create an event that says change the address. Think of the event as like a command. This is something that's you're telling something data changes in your system. So we change the address. The important aspect of events now is we have a log of them. Events are only ever added; they're never removed. And so the application state can be set up as a series of steps to build up it, which means we can create. At any given point in the system, we can recreate the database just by replaying the logs through the system. So what you do is, while you're switching from blue to green, you just keep a record of all of the events that happen on both systems. You replay it when the system changes over. Any new events that happen in green, if you need to roll back, are shoved over to the blue environment so that they can rebuild their data. This log can be stored in the database. It could be stored in its own database. You can store it in just a flat log file. You usually want to not use database, like insert, delete statements, because the state of the database may change. You want your app to support, so you use business logic in your event. Gives you a little more flexibility there.
So are you saying to then avoid doing something like Oracle using redo logs?
Nope, you can do that. It's a little tricky when you transfer between two oracles, right? Though. So I personally, this is not gospel, but I personally prefer to have it at the application layer where the application itself knows how to rebuild these events. You get a lot of other advantages from but having and being able to it's also you can use it for a logging point of view. When you know something went wrong, you can actually find the events that went wrong. So, but you can use all sorts of tricks. I personally prefer to have it at the application as a developer. That's not fun.
So would you start this logging just before you make the switch? I suppose leaving it on all the time.
Yeah, I personally would leave it on with truncating, so removing old ones at a certain point. So basically, whenever you do a backup, you no longer need a lot of those events. As soon as you verify the backup actually works. But, I would say leaving it on all the time because you never really know when something horrible is going to happen. But you're right, like you can get millions of events. So truncating that based on backup strategy. Next is canary releasing. My personal favorite. So say you have all of your users are going through the router and connecting to your app. Say you shave off 10% of those and send them to the new host. This Google does this, Netflix does this. This gives you a lot of capabilities in gradually getting people to try your app. We'll talk about it. So rollback is, yeah, go ahead.
Why is it called canary release?
It's a canary in a mine shaft was used to decide, I think, like if oxygen was low or something. But basically, the canary died what people died.
Methane gas.
Well, methane gas, that's what it is. So if there's methane gas and then the canary dies, people say, oh no, and they run away. So having a subset of your users, when things go wrong for that subset of the users, you can know, without affecting most of your people, that things are bad. Which means that you may have some disgruntled users, but at least it's a smaller portion of that. So with blue-green, you would be switching everyone over, finding out that everyone can't connect, bad things are happening, you have to switch them all back. With this, you can get a smaller portion, you have less of an impact on your business. So rollback is simple for this because we're just routing a percentage of your users. You can just reroute them back to the original one. This gives you capability into A/B testing. Netflix actually uses this quite a bit. When they want to test out recommendation engines, they're constantly trying to tune how to tell you what movies you would like. So if they want to test out a new recommendation engine, they give it to 10% of their users or their power users or something like that. And they actually have hard data to know if those recommendations are useful. So they can even, I'm not sure if they automate it or not, they could, where they could automatically see how useful this is, if they're getting a higher percentage of hits on their new recommendation engine, then they can switch everyone over. If it's less, then they just scrap it and try something else. You can also use it to gradually ensure that we meet capacity requirements. Capacity requirements are really difficult to test. Having a million fake users to prove out that your system won't die a horrible death, really difficult to test. So if you can, say, have 10% of your users trying the app, assume the capacity works, add another 10%, add another 40%. You can gradually build this up, and you can watch your capacity and see if you hit any plateaus or hit any issues. Very, very valuable. What does it take to do areas? The big thing here, you must have a database that works with all currently running versions. Which means that you need to upgrade your database independently of upgrading your application. We're going to talk a little bit about how you need to do that. But if you can make it work, you get so much benefit out of it. How do we handle emergency fixes? All of a sudden, you put something out there, and your 10% power users have an issue where they can't log in or they can't connect to a certain part of the app that they care about. So there's 3 good options and 1 really bad option. What we can do here. Probably the best one I would say is just roll back to the earlier version. When we're set up in such a way that we can deploy frequently, if we roll back a feature, it doesn't matter near as much because you know that within a day or so, you're going to have that feature back with a bug fix. You can just ignore it. Again, you know that you're going to be releasing frequently, so within a week or so, in your next iteration, you may have the fix in. It may not be a big deal. Your users might get over it. Or you can just follow your normal process and shove the bug in at the beginning and let it follow through the entire testing cycle. This means that you'll want to have this as fast and as automated as possible, which is, again, a really good thing. The bad option, which I didn't put it up here, bad option, is to have somebody manually hop onto the machine and patch it itself. This happens way too frequently. This is completely sidestepping every process that we've built in to ensure quality. Also, we don't know that, so besides the fact that they may be introducing new bugs while they're doing it, we also don't ever know what's in a particular environment if we allow people to just log on and make changes. Having the visibility to know that version 1.2 of our app, which means source code 763, having that visibility means that everyone knows exactly what is in production. Having somebody being able to log on and tweak it. Continuous deployment as opposed to, yeah?
Have you ever worked in a situation where rollback was too easy and people got a little too trigger happy rolling back for spelling mistakes or IE5 not rendering properly, that kind of stuff?
I haven't actually been in those situations, but I think it's important to understand that rolling back is it needs to be a very visible decision, and everyone needs to understand why we're doing this. Which is why I think that like in those cases, this would be perfect for ignore it. Like a spelling mistake, it's all right. IE might be okay because if your business is dependent on those users, that might make sense. But I think a core aspect of this is visibility across everyone, so that even though anyone can do it, everyone knows why they did it. So if it's something trivial, then there may need to be a conversation about why are you doing that.
Who do you normally get to say your name for a rollback in your experience?
Usually there's an ops person and a dev member that are working together, and they kind of make that call while they're working. So it's useful to have both because operations understands the system itself and the interactions between a bunch of things. The developers know, oh yeah, I did that. All right, so continuous deployment. As I think I've pointed out, continuous delivery is not the same thing as continuous deployment. Continuous deployment may be part of continuous delivery, but there may be that you have compliance issues that you need to have somebody manually looking at it. You may need to have a manual testing stage to verify that things are working. Although you can kind of get around it, it kind of covers that. So what is it? It's effectively deploying every good build to production automatically. This cuts out making decisions. If all the test maps, it goes into part of going into production, what this means is we need automation end-to-end. From checking in, running all the tests, deploying, ensuring that it's working. It may involve, with the Canary release, it may be involved automatically setting it up so 10% of the users can connect to it, and it manually or automatically tests capacity. It ensures that the server is not coming to a crash and can roll back. You can automate all of that. So having this What this does, though, is it reduces the risk of each individual deployment. Again, you know that the next check-in, which may happen in 10 minutes, is going into production after you. If something goes wrong, it doesn't mean as much. And again, since we're automating the rollback, and again, you need to have some sort of manual way to say, no, because you missed something with the automated test. But having it automatically go into production reduces a lot of the risk of individual deployments. So databases. So say we have the database and we need to make a change to the schema. So we need add a column, change a column. What we need to do that is a migration script. The script could be a data definition language that says, create this table. Data manipulation language that says, alter this column. The important thing here is that it's just a flat file with the steps that need to happen to make the database go from version 1 to version 2, to migrate from one to the other. And this script is actually shoved into the version control system. Keep in mind, this doesn't mean having a single script that is steps between all of them. You have a migration script for every transition that happens in the database. It may be associated with a story, it may be associated with a feature. But the fundamental part is, over time, we're incrementally designing the database. We're building it up, so we can say if we're at version 42 of the database right now, and we need to be at 45 for our app, that it can have some sort of automated way to go from those versions and build up the database. DB deploy, I've used quite well. And do you know have any others?
Sure. We use Bearing, which is a Groovy-based migration framework. There's lots of alternatives.
Yeah, there's a bunch of them out there. But the important thing is being able to version control it and having some way of tying what version of the database you need to your application. And this could involve downgrading as well. Downgrading has its own set of problems with the database. You could lose data with a migration, and getting that back is difficult if you don't plan ahead. But it's very important. A good,
Sorry.
yeah.
Does it mean that you should store also rollback script? Say, alter, add column means that you should store remove column or something like
Yep.
that?
Yeah, so it depends. Usually, yes, I would say. Sometimes that's really difficult. On the one project I was on, we decided to completely not deal with downgrading scripts because it was hard, and we could ensure that we would be backing up the database on an install, and we would just restore the old database. It didn't matter if we lost some of the data after the upgrade. So, but like DB deploy, for example, within a single script, the top part is upgrade, and the bottom part is downgrade scripts. And it's smart enough to know which to use depending on what direction you're going. So an excellent book for understanding how to deal with databases in an agile environment is Refactoring Databases by Scott. You should check it out. So getting back to the canary release problem, you need to decouple your application upgrades and your database upgrades. So what that means is, if say you want to delete a column in a database, obviously your application currently cares about that. So what you first do is you release a version of your application that it won't fail if that column is not there. So it will check to see if the column's there, or just have some sort of exception handling to handle that situation. You deploy that app without changing the database enough. You let that run for a little bit to ensure that you didn't introduce any new bugs. Then you upgrade the database. Again, let's ensure that nothing horrible is happening. And then you do a new version of your app that no longer has that extra check to make sure that the column exists. It takes a little bit of extra work, but having that capability to deploy separately, then it gives you more flexibility, especially with the canary release itself, where you can, especially since database changes are actually relatively infrequent. Having them decoupled is not usually a big issue. So I'd like to talk a little bit about feature branching and their impact on continuous integration. So this is the kind of typical continuous integration style workflow. The developer works on his machine, runs a build, green. They pull from the SVN or whatever version control system. There's a local merge, runs the build again. It's green. Checks it in. The continuous integration server will run a build and verify that it works. An important point to this is everyone commits to the mainline every day. This forces you to constantly be integrating with everyone else. So you know as soon as you possibly can when you have conflicting changes, conflicting ideas of the design. Martin Fowler's continuous integration page, he lists a bunch of things that are important to this. One thing I'd like to point out though, maintain a single source repository. Everyone is working with the same source repository. Everyone commits to mainline, and every commit should build the mainline on some separate integration machine. This helps avoid the works on my machine problem, where a developer thinks that the build is working, but they forgot to check in a dependent library, for example. You need to have something building somewhere else to verify that the build is good. An excellent book for understanding this is Continuous Integration by Holly Long. Let's talk about feature branching now. Yeah?
That means then that every day you want to be able to commit code that's going to go fine.
Yep. Correct. It gets back to if it fails, fix it. Like stop what you're doing. Make sure that everyone is on this, because you need to have confidence that your build is working at any given point. And it also comes back to being able to release it at any given point. Okay, so let's have a little example here. A feature branch. So we have Professor Plum and Reverend Green. They are working on their own feature branches. Professor Plum does a couple check-ins, Reverend Green does one. Somebody checks into mainline with a bug fix. This is pretty standard how you do feature branching. So Professor Plum sees the bug fix. She pulls it in, does a merge. Reverend Green, he sees it, he pulls it in, does another merge. No big deal right now. Again, another bug fix, another merge. This seems to be working pretty well. The problem happens when Professor Plum finishes her feature. She pushes it into mainline, and now Reverend Green has to do a merge of everything Professor Plum did, which could be days, weeks, could be a while. So there's significant change in the code that Professor Reverend Green has to deal with. Let's contrast this with continuous integration. Reverend Green makes a change, checks it right back into mainline. Professor Plum sees that change, does a merge, pushes it back, there's a bug fix. This is constantly going back and forth and back and forth. They're each working kind of in their own space, but they're ensuring that what every other person does affects them. Or that they see it as soon as they possibly can. So, what happens when Professor Plum and Reverend Green refactor? They make some changes to the structure of the code that is very similar. It's very close to each other. It's going to cause a conflict. With a feature branch, it's not until Professor Plum finishes her feature and pushes it in do they actually find out about this pretty major conflict. There could have been a lot of changes that are involved with this now. And this kind of merge is horrible. I've had to do that several times. You have to not only understand why they did the refactoring, but you have to understand all the code that is built on those assumptions of the design that they did. which you can have the conversation, but a lot of people don't remember what they were doing 3 days ago. So even those conversations are very difficult. As opposed to with continuous integration, again, they both do the same refactoring initially, have problems, can I finish this real quick? Do the same change. And they find out as soon as Professor Plum pulls that change in, they can have that conversation. They both just did it so that it's fresh in their heads.
Do you find that the developers are more hesitant to commit their changes because they know it's going into the main line as opposed to a feature branch?
When people get, it takes kind of a shift in a team mindset when it becomes everyone is responsible for the entire code base, this collective code ownership thing. You would rather find out you messed up earlier. If you're embarrassed that you messed up, then people tend to be more hesitant on it. But since everyone is doing it, it seems to me that people, once they get used to it, they start to not care. Sometimes they're doing some pretty major changes and they want to keep that separate. It's usually better as a team to make the decision of figuring out how to incrementally do that major change. Sometimes it's really hard, but
Let's say at the end of the day, they're in a rush to get home,
Yep.
and rather than commit to the main line, they just basically wait till the next morning, just so they have more time to solve it if it.
yeah, I personally don't have a problem with that. I don't. I would rather they not push it at all and do it the next morning, personally.
But I'm wondering if there's a different psyche in terms of whether it's on a feature branch or on the main line. Or does it not make any difference?
I don't think it makes a difference. People, there may be more of a tendency to check in smaller releases. On one project I was on, we actually experimented with feature branches. We're using the Git source control system, so it allows branching really easy. And we did find that there were a lot more smaller check-ins that could be rolled back into a single patch, into a single check-in, that people didn't really want to have 50 check-ins in an hour, but it gave them a little more feeling like they could do it now. The difficulties with feature branches is really what threw us away from that. But it does have a bit of a difference I've seen, but not a big one. Once you get used to having everyone's code is constantly there, the advantages as a developer become so huge. Just knowing as soon as you possibly can that two people have different ideas of what is a good design on a certain project.
So do you find that there's certain code revision styles that encourage continuous integration better? Like for some of our projects, we've just switched to using Git, and part of the idea was around the idea of feature branching because it is so easy to branch. But then that doesn't necessarily ever run into the main line all the time, right?
Right. So I wouldn't say feature branches are bad. I would say that what you're doing is delaying the time between from when you know that there's going to be issues. The longer you delay it, the more difficulties you have. I would say if your feature branches last like a day or two, then that's not horrible. I would still prefer multiple times during the day. But and that's what we had on this team that we tried feature branching on. Was basically it was a day or two before we integrated. And a day or two didn't seem to have too big of a problem. We also had a good communication style on the team, so we knew when somebody was working the same part of the code base, we communicated it. So we didn't have to rely on CI as much.
But do you think something like, say, SVN that's not quite as easy as Git to branch with would have you more in the continuous integration mindset because you're more likely to be working on the same branches?
I think CI as a mindset is independent of that. It's a concept of I want to always know that what I'm working on fits with what everyone else is doing. It's kind of just a higher level thing. Git doesn't mean you have to use feature branches, right? The branching doesn't imply that. There's tricks you can use. Had this conversation a lot. Just trying to understand the feature branching concept of where you could be constantly merging between every single branch. explodes in complexity, but if you can automate it, then you might be able to do that. But it's not as useful because you still have like these three plus this one together, and it can be. In general, feature branches have a lot of difficulty with this problem, the refactoring problem. It tends to encourage people to not refactor as much because they know that making a design change will hurt them later. And that's a bad thing. We want to encourage it.
I found with Git that one of the key advantages is the stat feature. So if you are working on something and you need to get very quickly back to mainline, then you can just stash changes. And by applying that, it actually keeps you closer to mainline most of the time, rather than going off and creating your own extended local branch structure.
Yeah, that's actually a good point. We ended up doing part of that. Yeah.
With things like Git and Mercurial, you can do their distributed source control. So there's usually not one central main repository, and if there is, it's usually the one for the continuous integration server.
Yeah.
Have you worked in any situations where the continuous integration server can come down and visit your repository, build your code, do your acceptance testing, and do the hours and hours of testing on your major refactoring or something like that, so you can say, yeah, I'm sure this is going to work before you
Actually, we flipped it around on the go-to. We set up, we called it the personal build server, and it was just a bunch of, it was Go, we use our own tool. And it had about 5 or 6 agents that were available. And so instead of, we used Mercurial on the team, and instead of building on a local machine, we never did it anymore. We would push to this repository on this personal build server, and it would build, and it could distribute the load, so it could run the tests 5 at once. Our build, it gave us the capability of having our build take a little bit longer because we didn't have to tune it as much because we were distributing everything. So even though the build might take 15 minutes instead of 5, so instead of having to spend the time tuning it to get it back down to 5 minutes, we just shoved it onto this machine. And then as soon as that went green, then we could take our local, check it, and push it to the main server. So we kind of flipped it around the other.
Did you wind up using that a lot then?
Yeah, we used quite a bit. In fact, I think they still use it. Worked out really well. Yeah.
I can't remember what it's called, but I think Team City has that feature where you can do a test. You can test it.
Yeah, it's a pre-commit check-in.
Yeah, I think that's what it is.
So the concept of pre-commit check-in, I like it to a point. I don't like the automated part of checking it in because just because the test passed, you may not want to have it be committed into mainline. I think it's a feature in Team City to decide whether to actually check it in or not.
Yeah, I think it's configurable.
Yeah. So as long as you disable that, I think it's a great. What we found though is a lot of times we would just push things we know were failing because we wanted to see if a certain part of it failed. It's just faster. We can shove it up there. We know that we're going to be updating the patch. We worked with patch queues in Mercurial, which is a lot like the stashing thing, where you can just rebuild on top of mainline. And so we just shove something up there, see if it works, and we could continue developing on our local machine. We could run quick builds on our local machine because it wasn't impacted by what's happening on the personal build. Yeah, so this is just another way to look at the feature branches versus continuous integration. Constantly working in the middle there versus waiting to the very end to decide to release it. So there's 2 other types of branches that are more common. Release branches, very common. These avoid a lot of the problems of feature branches just because they're always moving towards trunk. The longer the release lasts, though, the more difficult that merge can be. But it's usually not a big deal because you're almost always, at this point, talking about bug fixes. So you have something very focused. You know exactly what the problem you're trying to fix. So even if you can't get a clean merge up into trunk, you at least can rewrite it in such a way that the bug is fixed in all versions. And then the other one is an experimental branch if you need to spike something out, try something new. This is not a problem because we never touch trunk ever because we're going to throw the branch away. Experimental branches should never be merged back into mainline. If experimenting, then you should use that for the learning, not for the coding. All right, okay, timed that pretty well. So it looks like we have some business cards here. Oh, and did anyone else need to put their card in? Oh, and I'll have you do the honors.
My card's in there too, so. It's also right at the top. So that wouldn't exactly be fair.
I'll let you do one, and then I'll walk around.
Okay, Kevin Mooney, Philip Taylor North.
This is my colleague. Again.
Okay, I don't have the books with me because the saleswoman that was going to be joining me was bringing the books, and she got sick, and so she wasn't able to make it. So we'll be mailing these out to you. Emailing you to get. Here, you want to drop it?
Aaron Rodgers?
Try it.
Wait a minute.
Just get something in the middle.
Yeah. Chris and Denny SmartNet? Yeah?
Cool. Now you're safe to drop.
Jay Sarah?
Okay, cool. So, like I said, we'll get these books to you as soon as I get my salesperson not on sale. Okay.